So a nice simple example of electrolysis now. Molten lead bromide will conduct electricity. So we've taken the lead bromide that was solid and we've made it a liquid by heating it. What apparatus do we need? We need a beaker to put the lead bromide in. Okay, and we need to put 2 electrodes into it. Now, electrodes have names. We have a positive electrode and negative electrode, and we call the positive electrode the anode. And that's what we always call a positive electrode, and we call a negative electrode the cathode. I remember the difference between these because I despise cats. Flea-ridden, horrible, vermin-like creatures. So my feelings about cats are very negative. So the cathode, is the negative electrode. That's how I remember it. Now into that, we put those electrodes into the liquid undergoing electrolysis. This has to be liquid. Okay, will not work with solid. Liquid, and a liquid ionic substance undergoing electrolysis. In this case, it's liquid or molten lead bromide. So that's pure lead bromide, just been heated up and melted. Okay, so that would be made of Pb2 plus ions and Br minus ions. So we made billions of those. Now the liquid we're electrolyzing is called the electrolyte. So the liquid lead bromide, that is called the electrolyte. And any ionic substance that undergoes electrolysis is called the electrolyte. Right, these ions here, they have names as well. Like the anode and the cathode have names, these have names. Now when we turn the current on, the 2 plus ion, the Pb2 plus ion, that is attracted to the negative electrode. Remember, opposites attract, true in life and in relationships, and also with ions and electrolysis. The positive ion is attracted to the negative electrode. The negative electrode is called the cathode. So the ion that is attracted to the cathode is called the cation. Okay, the Pb2 plus, is called the cation. I actually think that's a bit confusing because the negative electrode is the cathode, but actually it's the positive ion that's the cation. We remember it because the cation is the ion that's attracted to the cathode and opposites attract. To be honest with you, I just remember, as I said, the cathode is negative, then everything else is opposite. If the cathode is negative, the anode must be positive. If the cathode is negative, the ion attracted to it must be positive. That's how I remember it. You need to find a way to remember that. The bromide ion, when it touches that electrode, when it goes to the anode, therefore it is called the anion. So the Br minus, that's the anion. Now the electrodes are made from carbon. We make the electrodes from carbon because carbon conducts electricity. Carbon graphite is the only non-metal that conducts electricity. Why? Because it has delocalized electrons. Okay, and the electrons therefore can move in the carbon electrodes. We don't use metal electrodes because the metal electrodes could get involved in the reaction. So why are carbon electrodes used? That's this question down here. Because they conduct electricity and don't get involved in the reaction. All right. So back to this question here. What happens when the electric current is turned on? Well, when the electric current is turned on, the bromide ion is attracted to the positive electrode, and the lead ion is attracted to the negative electrode. The bromide ion is attracted to the positive electrode, the lead ion is attracted to the negative electrode. When they touch those electrodes, the ion turns back into the element. So the bromide ion touches the electrode and immediately forms bromine. And bromine would be a liquid at room temperature, but this is molten, so it's been heated up, so it's actually going to be a gas. And it's going to, you would see it therefore bubbling off at these electrodes, and you would get bubbles of bromine gas given off at those electrodes. So the Br minus ion touches it and turns into the bromine molecule. Now the reality is we would need 2 bromide ions, okay, to make 1 bromine molecule, because it's a Br2 molecule. The lead ion touches the electrode and immediately turns back into lead metal. Now this is very hot here, and lead, when it's a metal, is very dense. So what we would end up with is some pooling of lead down the bottom here, pure lead metal. So what happens when you turn the current on? The bromide ion moves to the anode. The anode is the positive electrode and turns into Br2 gas. The lead, the Pb2 plus ion, the lead ion, the Pb2 plus ion moves to the cathode. Cathode is the negative electrode and turns into Pb metal, elemental lead if you like. Pb with that charge. Note, in each case, the bromide ion becomes the bromine molecule. Charged, not charged. The ion is charged, the product, the element is not charged, and the same with the lead. So down here now, and this is now going to help us write half equations. So all we're doing down here is repeating in these questions what we've said here. What travels to the anode? Let's just write after anode positive, because that just helps me picture. What travels to the anode? The bromide ion. What is made at the anode? Bromine gas. This is what happens in electrolysis. The ion turns into the element. What travels to the cathode? What travels to the cathode is Pb2+, because of course the cathode is negative. What does it turn into when it's made there? Lead, Pb. Right, so now the difficult bit. Can we do half equations? Well, the anode was positive. The cathode was negative. Let's do the cathode first. The Pb2+ ion, the lead ion, goes to the electrode and turns into lead. So all this half equation is going to do is tell the story of what happened here. The lead ion goes to the electrode and turns into lead. The bromide ion goes to the electrode and turns into bromine. So we're just telling the story of what happened. Okay? The bromide ion touches the electrode and turns into bromine. Okay, now the first thing we've got to do with these half equations is we've got to balance them out. At the moment this is balanced. We've got one Pb there, I've got one Pb there, but the bromide isn't. One bromide, two bromines. So that's not balanced. So we're going to need two bromide ions to make one bromine molecule. Now, the question is, how does this happen? And the answer is, it's going to involve electrons. Electrolysis involves electrons. Okay? Now, you have to decide whether this Pb ion here, this lead ion, this Pb2+ ion, gains electrons or loses electrons to become Pb. Now, a nice easy way to remember this, I think, is just to think of a number, just any number really, any small number. So let's think of 4. And let's imagine lead has 4 protons. It has far more than 4 protons in reality. Okay, let's just say it has 4. Now, this is a Pb2+ charge. So if this were Pb2+, then all these protons must be balanced out with an electron. Okay, so protons are positively charged, electrons are negatively charged. All these protons must be balanced out with electrons, apart from 2, because it's got a 2+ charge. So that electron there I've just drawn in, electrons negative, balances out that proton positive. So this, if it were like that, it would have 3 positives left on its own. It's got 2 positives. So let's just say it has another electron. And that now leaves 2 protons on their own over here. Ions are always charged, so they have an imbalance of electrons. They either have too many or too few. The protons live in the nucleus and never change. Right, on the other side, here's lead, Pb over here. We're still, if it had 4 protons here, it must have 4 protons here. There we go, 4 protons. This time there is no charge, so the number of electrons must entirely equal the number of protons. So what you have to ask yourself is, what's the difference between this one here and this one here? This has an imbalance, and this has entirely equal. Well, the answer is we need to give this one 2 extra electrons. The lead ion is going to need to gain 2 electrons to turn into this. So we need to write here plus 2e minus. So, and you can write this into a sentence if you want to. The lead ion, that plus there means gains. This here is 2 electrons. This means to become. And over here we have lead metal. Okay, so the bromide ion, using the same logic. I used 4 as a number last time, let's use 5 as a number this time. Okay, so let's put 5 positives there, 2, 3, 4, 5. Now this is Br minus. So every one of these positives, these protons, must be balanced by an electron, but it's gonna have 1 extra electron there, 1 extra electron. That's the negative. Over here, this is bromine gas, so 5 positives, because that's not going to change. Protons live in the nucleus, they never change. Bromine has got far more than 5 protons. I know that's not right. We're just trying to picture it here. 5 protons, and it's neutrally charged. It's the element, so it's neutrally charged, so we must have 5 electrons. That balances out each and every proton and electron, so there's no overall charge. Question, how do we turn from this side into this side? Answer, we lost this electron. Now you might want to write minus an electron here. That would be technically accurate, I suppose. But this is a chemical equation, and chemical equations have reactants and products. Okay, so we don't write minus, we write reactants and products. The bromide ion is giving off, is losing an electron. That means an electron is a product. The bromide ion is losing an electron, so it is a product, it is produced. Now you may think that's right, but it's not technically balanced correctly because we've got 2 bromide ions. 1 bromide ion loses 1 electron, 2 bromide ions lose 2 electrons. The last bit, oxidation reduction. And the clue here is oil rig. Okay, that's a mnemonic. It helps you remember oxidation and reduction. Oil rig. Okay, very simple, oxidation. I always write it like this. Oxidation is loss of electrons. And reduction is gain of electrons. Now, I always think it's easier to spot reduction than it is oxidation, so let's look at that with this last example. Reduction is gain of electrons, that's what oil rig is. Oxidation, loss of electrons. Reduction is gain of electrons. Okay, up here, back up to here. So I always think I say reduction is easy to spot. Reduction is gain of electrons, gain. So we wrote here, lead ion gains 2 electrons. The lead ion, okay, is being therefore reduced. The Pb2 plus ion, the lead ion, that's being reduced. Oxidation is loss of electrons. So the bromide ion, if you remember, was giving off electrons. The bromide ion was giving off electrons. Electrons were produced. So the bromide ion lost electrons. That was like, is possibly a bit harder to spot. Oxidation is loss of electrons. So we said the bromide ion. Okay, we say the bromide ion, not bromine. Bromine is very different. Look over here. The bromine isn't losing electrons, okay? The bromide ion is losing electrons. So the Br minus ion, the bromide ion, is losing electrons.